Okay, so today, guys, we're going to start looking at, instead of linear regression models, we're going to start our journey into other types of regression models. And then once we learn some more functions, we'll come back to this and look at regression models with those functions from our library as well. So the only other prominent function that we know real well so far is the parabola. So we're going to look at parabolic or quadratic regression models today. We're going to do that the same kind of way that we did those ones a second ago. We'll start out with this example from the book where we're looking at old-time film. And the length, like that came on reels, like the really old ones, that came on reels, and we're going to make some predictions about how long the reel is based on how big around it was, and also how long the movie is based on how big around the reel was. Okay, so we'll do a couple different predictions with that, and then we're going to move on and do something a little bit new, but a little bit old at the same time. So I'll show you that in a second. So let's put these in our scatter plot. So I'm going to go to my lists. And enter them. So list one, I think we're going to make our predictions. It says find a model for runtime given diameter. So that means given diameter, that's the explanatory variable, that's the x. So we want to put that in for list one. So 5, 7, 9.25, 10.5, 12.25, 13.75. There we go. And the lengths. And the run times. Did I make a mistake? Or is it? Oh, thank you. So do I have to start over? Second insert. Magic. Thank you, Rachel. That's nice, yeah, especially if you have a list of like 40 things that you're entering, which sometimes we do in other classes. Yeah? Logan's like, man, that would have saved me earlier. Dang it, yeah, I'm sorry I never showed you guys that. Yeah, crazy, dang it. See, these guys know that that's a useful little trick. So, okay, sorry I never showed you before. All right, let's look at the scatter plots first and see if we indeed do need a parabolic regression model. Or is it something else? We're going to go back and look at three features, right? So scatter plot. Let's look at list 1 versus list 2 first. So turn my plot on, it's ready to go. I press zoom what? Zoom 9. So there we go, there's our first scatter plot. So three features, what do you guys think on this scatter plot? It's curved, it's nonlinear. A parabola might fit it okay, right? Is it strong, weak, moderate? Strong. And positive, right? There we go. So let's create the model for it. Now I went list 1 versus list 2, so am I doing the R model or the L model? Runtime is list 3, real length is list 2, so I'm doing this one, right? So let's create that model. You create it by the same kind of way we've done before. Stat, calculate. This isn't a linear regression, it's a quadratic regression. You can say list 1, list 2. If you just press enter right there, it's usually like the default, and it'll take list 1 and list 2. But see, we're going to use other lists today too, so you got to be able to specify. So there we go. There's the model. Quadratic regressions don't have an R, they do have an R squared. I'll explain what R squared is at the end of the semester. Okay? I want to overload you right now. So let's write it down. Remember, that's calculator barf. I don't want calculator barf. I want a parabola. The calculator bar shows you how to make a parabola. I'm sorry I'm so graphic, but when people put that on their paper, I'm like, oh. So the first coefficient, A, is 14.305 about x squared. And then we have minus 112.406. Notice I'm rounding. And then plus 430.110. I'd recommend keeping at least that many decimal places. If you don't, sometimes when we're doing more advanced problems, you'll have issues. I'm sure we'll see that come up this year. Okay? So there we go. We could even type that in and see if it's fitting it appropriately. Now yesterday I showed the other class how to do something neat. You could just type that in right straight up right here. Yeah? Or It's saved in your calculator somewhere. The only question is where. I go to vars. And then I look around for something I've seen before. Oh, I've seen statistics before. None of that stuff looks familiar. Nah, it doesn't look familiar. Any of that stuff look familiar? Yeah. Do we just have A, B, and C? And what's reg EQ mean? Regression equation, which is what we just have. So if it's out on your home screen, watch. It just pumped the whole thing in there. Yeah? I think it did. Let's see. Oh, did it screw up? Yeah, it did screw up. Yeah, it did screw up. Most of the time this will work though. So the longer way to do it is to go like this. If you want full precision, you can go vars statistics a x squared plus vars statistics. This is too long. This is a waste of time, but just to show you guys the principle. There we go. And there's our parabola of best fit that we just created. Obviously, it's fitting them pretty good, right? Whether it touches the actual points is irrelevant. We don't care. We're not playing dot to dot here, okay? But it's following the trend nice and tight. All right, so we could make a prediction with that. So out on the home screen, I could just type that in. Once again, I could type in this purple stuff and stick in whatever they gave me. Like if they wanted to know what the real length was for a diameter of, let's say, x equals 6. That's not an extrapolation. You could do it that way, or you could be smart. I have this saved in Y1, so I can go vars, yvars, function, Y1, and just plug it in. There's the real length for 6 diameter, for a 6, I guess these are inches, 6-inch diameter. If I wanted to know for 8-inch, watch how fast it can make these predictions. I'm starting to show you calculator stuff, which will make your life a lot easier if you try and explore it some. So you don't have to. If you get lost, hit second quit, or do it the longer way. I'm telling you, if you learn this stuff now, it'll make your life easier. Yes, Ms. Peters?
Sorry, how do you get to, like, the equation to go down to the next line? Like,
where?
How you got Y1?
Oh, I hit second entry.
Oh. Okay.
Second equals, or second enter. Yeah? Yeah, that's really nice. It's a nice one. Okay. All right, so I'm not going to make too many predictions. Let's just create our other model because we've got a lot to do today. So now I want to create a model, R hat, to predict runtime from diameter. That's list 1 and list 3. So let's go look at that scatter plot first. So I'm going to go to my scatter plot and say list 1 versus list 3. I need to rezoom because if you just look at your graph now, you've got all kinds of funky junk on it from a second ago, right? I don't want that old parabola on there anymore. I'm deleting that. I can't see those points at all hardly. What do I have to press? I need to rezoom it. Thank you, Josh. There you go. This one looks pretty similar once it's been rezoomed, but obviously it's not the same because this is a totally different window. You could, of course, press the window if you want to see what it really is. But let's create the model for this one. I bet it's not the same as the purple. So now I've got that. So I'm going to say stat, calculate, quadratic regression. What do I have to put here? List 1 and list 3. So that's key. If on your problem, if you want to make sure that you don't get lost, it's really good to label these. Like this is list 1, this is list 2, this is list 3. I think that really helps. So. Alright, you can see that's a totally different parabola. This parabola is going to be 0.397x squared minus 3.120x plus 11.938. A totally different parabola. Then you could throw numbers in it and make predictions just as easily. You could do them the fancy way I did, or you could do it just type it into your home screen. It'll work. Okay. So there's a couple examples of parabolic regression, and I showed you a bunch of fancy calculator features. I'd really encourage you to work with those. It'll make you a lot stronger, faster, and make your life more fun with mathematics. I'll see you next time. Okay, so the other thing that's in this section is making a parabola that has a perfect fit. If you don't have a scatter plot full of a lot of points, you just have 3 points. 3 points is enough to determine a perfect parabola. 2's not enough. 2's not enough information. I think we can see why if we set up the system of equations. So this is going to review some important stuff about systems as well. So each one of those points gives you kind of one piece of information. What's the general polynomial form of a parabola again? Can you guys help me? We just worked with it a second ago. There you go. So in order to find a parabola that perfectly fits these guys, in other words, that kind of has like an R of 1, and that goes through all of them, we need to find how many coefficients? 1, 2, and 3. On those other scatter plots a second ago, the calculator goes through some really advanced stuff to find the best ones that fit the best. But see, since there's only 3 points here, we can find not only the ones that fit the best, but that fit perfectly. Each one of those will give us one piece of information. So plug it in. Here we go. When we plug 5 in, we get 5 out, and we get this when we plug it in. Right? So simplify that. That's 5 equals negative, or is that negative or positive?
Positive.
Positive. It's just 1a, right? So I'll just say a. And then over here we've got negative b and positive c. There is one equation. Second equation comes from this point. If I plug 3 in, what will I get? 5 again. 3 in, 5 out. So I go a times 3 squared now, plus b times 3 plus c. Simplify. You get 9a plus 3b plus c. There's one equation with a, b, and c. There's another equation with a, b, and c. If we want to solve for a, b, and c with a system, we need a third. Good thing we have a third point. That's why I'm saying you need 3 points to make a perfect parabola. So now I'm going to say when I put 4 in, what comes out? 16 comes out. So that's going to be a times 4 squared plus b times 4 plus c. So that's going to be 16 equals 16a plus 4b plus c. Now that is a system of equations. You can solve it various ways. On your assignment this weekend, so this goes back to last unit. I didn't have you guys end up doing more of that then. I'm having you do it now. Okay? It's very important to be able to solve 3x3 systems. So I want you to solve a couple of them. You guys will note on your homework. And I did things in reverse order. Please go in the order I asked you to do it in. There's a couple of them I want you to use matrices on your calculator on, and then there's a couple of them I want you to solve by hand with elimination. I'm going to show you how to do this problem both ways. We'll start with the fast, easy way with our calculator. So, writing out the system, I've got 5 equals, let's write it the other way. You guys are used to seeing it like this. A minus b plus c equals 5. That's the blue one. The red one is 9a plus 3b plus c also equals 5. And the green one we got from the third point is 16a plus 4b plus c equals 16. That's a system of equations. It looks just like what we've done before. Turn it into a matrix equation. So, peeling off the coefficients. 1, minus 1, and 1. 9, 3, and 1. 16, 4, and 1. That's matrix A. My unknowns are not x, y, and z like we had before. What are they? A, B, and C. A, B, and C. That's the variable matrix X. These are multiplied. And then over here I have my other constants. How do we solve A times X equals B and matrix land? Remind me, Kyle?
You multiply across and down.
Well, this multiplication, remember, the reason this is because when you multiply matrices, you go 1a plus negative b plus c equals 5. That's why this is this. But how do I solve for x here? How do I get rid of a? I use the inverse, thank you. So this is something you don't want to forget. You're going to need it in future classes. So this is x equals a inverse times b. But I'm not going to do that by hand. I'm just going to have my calculator do all that work for me. So it's a good review. Some pretty important stuff. And also very relevant to parabolic regression. So let's have our calculator do that. I'm going to erase this stuff. And just have my calculator do it. That should be fast. Okay, so I go to my matrix menu, second matrix, second matrix, go and edit. A is a 3 by 3, so I load it up. Quit. Go back to my matrix edit. B is a 3 by 1. And then I tell my calculator to do exactly what we had in theory here. When you do these, I want to see exactly this work. I want to see the system, I want to see the matrix equation, and I want to see the theory. And then you can just give me what your calculator gave you. Why do I want to see this theory? It's not hard theory. It's basically dividing on both sides. Except the matrix line, remember, there's no division. So I'm going to tell my calculator to go second matrix, A, find its inverse, and then multiply that by second matrix, B. And there is the answer. But what was I trying to find all along? I was trying to find the parabola that went through those 3 points. Those are the coefficients of that parabola. So the parabola that we've been wanting is f of x, or call it whatever you want, 2.2 x squared, because remember, this is a, minus 4.4x minus 1.6. Let's check our work. I'm going to put these in my lists and see if that parabola does indeed go through all 3 of those points. So you guys don't have to do this every time you do one, but just so you can see what we just did, the power of it. -1, 3, and 4, 5, 5, and 16. Zoom. Uh-oh, better make sure my plot's on the right thing. It's not. List 1, list 2. Zoom 9. There's the 3 points, kind of chilling out in the middle of nowhere. See if our parabola goes through them. So this is where we need some, like, drums. You guys give me some drums? Yes! Okay. So this should make you feel pretty powerful, I think, if you get these correct. Let's see how to get these by hand instead of with matrices. I love matrices. I'm hoping you do too. May have been a little bit to, like, jog your memory on that, but it goes pretty fast once you learn how to do it. Doing it by elimination is a little bit not as much fun, but important. I think you guys still need the mechanics, so let's look at that. So Ashwin just told us that it'd be best to eliminate C first, because there's just 1 in each slot. I think that was a good idea. So we're going to multiply this by -1, so we have C minus C. So I'm going to show all my work just so we don't get any mistakes. And that's why I'm having you do this. The only reason is you guys make lots of mistakes still. So this is going to help you stop doing that. Elimination is adding. So this is 1 minus 9 is -8. -1 and -3 is -4. And we wanted those to go away, which they did. Oh, and this is 0 over here. Okay, sweet. That's still got 2 variables left in it, so we need to do another combination. Let's try to eliminate C in this one and this one. We can do it the same way. So that one I'm going to have, I'm just going to write the top one down again. Didn't modify it. And down here I'm going to have negative 16a minus 4b minus c is negative 16. Don't forget to multiply over here on this side. Lots of people make that mistake. Okay, so we've got 1 minus 16 is negative 15. Negative 1 and negative 4 is negative 5. And our c is eliminated just like we wanted. 5 minus 16 is negative 11. So there's one equation with a and b. There's another equation with a and b. You can do elimination again. It's going to get kind of ugly. Didn't we get decimal answers when we did it with our matrices? So you should anticipate this is going to get a little ugly. So let's see. We've got this guy. You know what? I'm not going to do it right there. I'm just going to use a different color so you guys can keep track. Okay. So what do you guys want to try to shoot for, A or B? Neither one's really a great choice. What's got smaller numbers? So B. So what do 4 and 5 both go into? 20. That's their lowest common multiple, right? So how do you make this 20? Times 5. So let's do that guy. So this is negative, ooh, I'm gonna go with black. I've got so many. Negative 40. Negative 20. 0. How do I make that 20? 4, except somebody said not 4, they told me. Why do you want to use negative 4? So that they'll cancel, right? Nice, okay, so now this is going to be 36, oh, it's like an hour. Okay, so 60. Negative and negative's positive. Negative and negative's positive 20. Gone like we wanted.
You got the negative, yeah.
What's this supposed to be? 44. Good. So then this is going to end up as 20a. This is going to end up as 44. So a finally is 44 over 20. Put that in your calculator. I remember what it was from a second ago. It's 2.2. So far we're getting the same answer that our calculator gave us with matrices. It's just harder and longer. But a very good exercise, so I want you guys to do it for sure. So now once I've got A, what do I do with A to find B or C? Plug it in where? We got lots of options. Where should I stick it? Which easiest one, Logan? Up on top? If I do that, then you're going to end up with 2 variables left again. You're going to have to do this all over again. It would work, but where else could you put it? That's smart, though. Could you put it in this one? Could you put it in this one? You can put it anywhere you want. This one has nice full numbers. I'm going to put it there. Negative 8 times 2.2 minus 4b equals 0. You guys need to help me out. What's negative 8 times 2.2? What do you got on that?
Negative 17.6.
17.6, thank you. So now we're going to add that to the other side. And finally, we're going to divide that guy by negative 4. What do you get? Negative 4.4 exactly? Is that what we had a second ago for matrices? Sweet deal. And now, we're going to take both those, and I think we should stick them where Logan told us, because now we have 2 of them. Put them in the easiest thing possible. So we'll stick those way back into here. 2.2 is A, minus a negative 4.4 for B, plus C is 5. That's plus, that's 6.6. Subtract. 5 minus 6.6 is negative 1.6. Is that what we had? I'm hoping so. I erased it. I shouldn't have.
Yeah.
So that tells us, just like with the other way tells us, that f of x is 2.2 x squared. minus 4.4x minus 1.6. And we just saw that that definitely goes through all 3 points. Okay, exciting.